Hello everyone, welcome to my YouTube channel. In this video, I'm gonna show you how to generate discrete time multi-frequency signals for 12 possible different symbols in dial keypad. I will do it step by step. Firstly, I will show you how to generate them. For this, let's see the code I've written. So firstly, we will initialize the variables. And in the dial pad, there are 12 different symbols, and for the rows, we have a low frequency group, which has 4 different frequency value. And also for the columns, we have a high frequency group, which has 3 frequency value. And in this part, we just create pairs. I mean, for each symbol, we have 1 low frequency and 1 high frequency. So for each symbol, there is a unique combination of them. So that's how that's why their signals are different on the graph. And also we just initialize the variables like sampling frequency. And the next part is visualizing and sounding digit symbols. For this, we firstly make it sinusoidal to show it on the graph, and then we just make the time. We just set the time to 100 milliseconds, but it depends on you. You can change it. And lastly, we just make it sound. I mean, for each digit, for each symbol, there is a unique sound, and you will see it now. Okay, let's move to second task. For this task, we will again initialize the variables, and the variables are almost the same. And when we go down, only difference is the input. We are getting input in this part. The input is for the number. We will create a number, we will dial a number, and the system will create an array for that. And also between each digit, there will be a silent period. And again, we will visualize the number which we have pressed in a dial keypad. For that, firstly we will open a loop, a for loop, create a for loop for each of 12 symbols, and also we will find the digit, which digit has been pressed. After that, we again make the signal sinusoidal, then we will plot it, and also we will play it by using the sound command. And then finally, the algorithm will create a number array with spaces between digits, which we want, which we desire, actually, which we purpose for this. And after the loop, we will create a time array for the plotting part, and after that, we will plot the whole number signal. Let's see how it works. First, it requires a phone number to dial. Let's write a phone number. Our number is 505-592-4592. And also you will see the numbers, the graphs of the numbers, the signals of the numbers. And in the next part, we will do another task. Imagine that you want to dial a number, you want to call a number, and you just dial the number, and the number you just press is sent to the phone company, the telecommunication company, and they need to decode the signal to determine which number we would like to call. And after that, they calculate the correlation between our signal and also each of 12 symbols DTMF signals. So that's how they just know which number we wanna call, and they just make the connection between the numbers, provide the communication between the numbers. And we will just make a simulation of it. Basically, in this task, the first part is again initializing part, and after that, we get the input and we put a silent period. After that, we visualize the number which we have pressed. Yes, these are the same with the previous ones, and also this part is a difference. When we look at here, we will see a correlation function. This function used to compute the similarities between two signals, and it creates a correlation coefficient and also lag, the delay. After that, we are supposed to normalize the amplitude of the signals, because we wanna set the maximum point to 1. So that's why we are using the normalizing function through this line. And what else to say? Yes, the title and labels. We just set the labels and also title, and it all looks okay. And let's see how it works. Yes, let's dial a phone number. Firstly, let me show you the graph of the number, signal of the number. Yes, the number is that, and our number is 531-690-2822. The number is this one, and also you will see the correlations. And when we look at the 1, for example, this is the correlation between the number and also digit of 1. We'll see that there is a one point where the correlation is equal to 1, and it corresponds to this number. The third number is 1, and when we correlate the number with that, we will see that in the third place there will be a correlation which is equal to 1. So it means that we are in a good way. And also let's check it the second. For that, how many 2's we have in our number? This one, and this one. We have 3 digits of 2, and we'll see that we have 3 points where the correlation coefficient is equal to 1. So it means that it's also true. And let's see finally the 3. When we have a look at the 3 in our number, we see that there is only 1 3, and also it's in the second place. And when we look at the graph, and there is a 1 point where the correlation coefficient is equal to 1, is in the second place. So it shows that the code is working properly. But I wanna tell you the just confusing part, which I don't understand at all, is that, for example, 4 is not included in our number, but when we look at the graph, it shows that there are 3 points where the correlation is equal to 1, but the others are all almost 0. So that means we have any number like that. If we have a few ones and also zeros, not the middle, just ones and zeros, it means that digit is not included in our number. And for this video, it's done, I guess. Thank you for listening to me, and it was a pleasure to share this work with you, and I will continue to share some projects or works which I have done in the future. Thank you for spending your time, and see you again in next videos.